Thank you very much. So that's the last presentation in English for today. I want to say before starting that I'm very happy to be here with you today, very honored, and it's presenting in front of customers and colleagues of Alive. I hope that you are enjoying the conference as much as I am doing, that you will find valuable information on my presentation that will be focusing on design, styling. Okay, that's my domain, but that could be interesting as well for other people. So I will introduce the goals of CATIA Design Solution briefly, and things that are driving our development and our commitment to the users, to you. And then I will illustrate the solution, not everything, but 3 axes: design workflow, collaborative design, and generative design. So let's start. So that's what we are trying to, that's our drivers. So we serve 3 communities: the creative designers, the modelers, surface modelers, and also anybody that needs to see what you do to make a decision. What we want to do is to provide a unified industrial design workflow solution, serving the purpose of our universe, 3D universe and virtual twin. We want to make sure that those people are embedded into the 3D world, that we have a good streamline between design and engineering and manufacturing to make it faster, but at the required quality to output the right product. And everything should be online. I say now online, keeping the design people, network all together, the data connected. Now you understand, I will not repeat about AI, but that's key for the next step to AI support, and that's what we call the virtual twin. I try to be fast, but yeah, I will again illustrate the previous values on 3 big topics. I will not explain everything, but I picked up some use cases that make sense, hopefully, for you. So let's start by the creation. So here, for the creative people, so create, model and experience. So the first one will be on a steer wheel 3D modeling in an MR environment. The second will be a loading, unloading of a trunk in VR and motion capture. And the third one will be about light animation with visual scripting. Okay, so let's start. So this is about MR modeling. Maybe you already know that we can do 3D sketches. We can do surfaces, subdivision surfaces quickly to bring the ideas into shape, into concept models. And a few years ago, we released the ability to make 3D sketches in VR. But you understand now, we link real and virtual. So what we delivered in 2025X is the ability to do it in mixed reality. So this is for a creative designer doing the steering wheel, but you can imagine that when you have the virtual twin, even in engineering or in manufacturing, you want to make it and say your colleague, I want to do this, I want to do that, and sketching is quite natural for everybody. So I'll move. The next one is also about experience, sustainable experience, you name it. So since Few released, also we deliver this. This is not so new. We know how to make quickly, easily, whatever the assembly you are doing in CATIA, VR experience and a motion capture. But we had still to improve the experience of the product to make it an experience, and what we were missing is the interaction with the 3D. So this is not the big thing. The geometry is divided inside an assembly, so there is no additional things, but you can incarnate yourself in the environment, grab, check, capture the replay, see various ways, including your customers, not your customer, to make sure that the experience of the product you output is the correct one, the one that you want to push to your engineering and manufacturing. So now we can, the video is in VR, but of course, we can do it in MR. So you just hide the incarnation, You see yourself, you see your hand, you grab it, then back to the system, you show again the incarnated. There is AI behind, but it's none your business. The way the mannequin is moving is optimized by an AI software behind. So this is, sorry, can you go up? So this is about light animation. This use case is a hot topic in automotive industry, but not only. And this is a combination of visual scripting, which is the application I will talk about later, combined, because it is in the same software, with our advanced capabilities of renderings. What we do is we tell the software, we have a parametric environment defining the number of LED, and we tell to activate the LED on a certain time, and we output the video of it within the rendering environment. So we have a good since 25x. Also, we are leveraging the power of NVIDIA RTX technology with a denoising of the image. That's why there is no noise in our light. So it's similar to what is used in game engines. So very, very good quality of the output in light. So next, I show you about the Imagine. I will talk about the surface modeler now. So this is just a quick reminder about our commitment to the market to provide you with the best-in-class tool for surface modeling, being concept to class A to surface to production-ready surfaces. So you know about ISM Surf or Alias, which is our competition. Very productive modeling workflow, but no history. So you're dead on the parametric field that you need to output to your engineering. And you know Katia ISM shape, you just saw with Yatang testimony. Very good parametric modeling, full history, fast design change, but modeling workflow is not so easy. And we know that the key to virtual twin is also our user acceptance and how easy it is to make it. So we've been developing the past few years, that was mainly my activity, ISM design experience, which trying to put the best of both worlds to combine history with a very good workflow, providing specific functions like a specific interface, mouse menus, ability to model in straight view, to output, to be able to combine parameters, sculptings, and analysis all together. So what you see is also specific shaders to have a better view of how beautiful is your product and how good quality it can be with a zebra. So today we believe that we have a very good level of maturity for base surfaces combined with ISM shape, which is for final details like fit, gaps, advanced fillet. We are delivering the most productive solution today. And last, about experience. So this is for decision making. I'm talking fast because I see the time at the same time. So this app is new in 25x. I will not show you everything about visualization, but focusing on light simulation. This app is called Validation Rendering, and it's an entry door to light design and simulation prior to final certification. So what we want to provide is something not necessarily for the final certification, for engineers, but more to democratize the light simulation to everybody, all our users. So what we do here is you can apply physically accurate light units and emissive light material with units, so you give a lux number to the sun, and then we provide also some specific algorithm to tune tone the rendering so that it fits, it's more natural to your eyes. Basically, you have a much better glare, much better glow of the product. It supports cluster of GPUs, multi-GPUs to boost the result to make it real time, because sometimes light simulation can take quite a lot of time. So I will go next. Yeah, and the second thing I wanted to show you is for design review, about user adoption. To go a step further to the video you show about human incarnation, we started to deliver also in 2025X finger tracking capabilities. So what you see here is an application called Product Perception Experience. It's for stylists, okay, it's my domain, but we see a big interest for manufacturing and engineering. I will show later another video that explains you this. What you can do here is to set and stage variations and configurations of your product, colors, positions, part configurations. You can replay kinematics, and then you can leave it, you can get into it in VR, in MR, and we try to minimize the hardware required to do it, like we start to do finger tracking to trigger the change, and so that you can do your decision. So that's it for the first item, unified design workflow. What you saw here is one single software. So hopefully it illustrates the way to move forward outputting a virtual twin, at least at the early stage of the product development. So next is about virtual twin, meaning what? Meaning one software environment common to design, engineering, and manufacturing. And it's something that it's something that people before Klaus explained he put together. We want to shift. We want to shift as early as possible the discovery of the issues in the process of design. So here, I will not talk about simulation. I just want to introduce briefly how we can do design iteration between styling and engineering on a use case of aerodynamics. So before you saw something else, maybe I will repeat again, but it's not about prediction this time. My use case is about actual simulation result sharing. So this is not the most simple case to put in place, but I hope it will help you understand the concept and value of the platform. So the goal and challenge, again, is to front-load as much as possible the discoveries of the issues, and then take decision on how to clear them. And it can be done at the designer level. So what does it mean? It means that to start checking the design with engineering requirement as soon as the first 3D models is available. And for this, you need to have a history-based modeling application, which is CATIA. You need to have a very robust simulation tool, which is Simulia. And you need to have a platform to orchestrate all of this data and put together the different teams, the different experts at the same place to make the design review. So let me go next. There is 2 videos about it. So this is CATIA Imagine and Shape. This is our subdivision modeling tool. It is used by modelers for concept models. Depending on the product you do, you can use it for, it's a good quality, good enough quality that it can be consumed by simulation. At this stage, the designers want to check their model versus a simulation result. So you saw before prediction, but here it's a little bit different. The model is already good quality, consumable by simulation, but the simulation is too difficult for designers. So the simulation engineer automated the process by giving a dashboard on the platform following a standard CFD process prepared for the designer, and the designer can trigger by himself the aerodynamic simulation. So maybe it's a step back compared to the previous presentation, but this is available since a few releases already and quite stable. So the goal is, of course, the designer doesn't want to disturb the friend because and too frequently. And then you see we can do it. Then it's about design review. So again, about the virtual twin. We don't have a design review different for engineers or different for modelers and designers. It's all together. People can come together on the same environment, mixing the simulation result and the virtual twin. That's what somehow some message I wanted to pass. So here the simulation result can be loaded in the concept of virtual twin. This is the video I showed you before, finger tracking, mixing with configuration of the product. It's not only for stylists, could be also for engineers. It's called Product Experience Presenter, by the way. So okay, I move. Then I go to my favorite. I thought it important to make a focus on a special app called visual scripting, which I love. I'm a user myself, so I can talk as well as a non-Dassault system person, maybe. But I heard before, this is not my speech, that everybody was talking about the parametric field. That's it, a parametric environment. But then you need to make the parametric environment. And it's not so easy so far. So I go next. With visual scripting, you have a fully parametric environment that comes on top of the core applications of CATIA, like part design, generative shape design that you saw before, or ISM shape design. So in the past, but rather currently, I feel that we are still using GSD and knowledgeware to make the parametric environment good enough for to feed the AI. So we make it smart, and people can use GSD, they can use knowledgeware, but it is not so easy because you require a lot of coding. So now with visual scripting, we make all accessible to 3D users. No worry, so because it's a graph-based. I won't show you a video, but you see that the spectrum, sorry, I come back. The spectrum is like this. So you have a direct visibility of the feature between feature at the parametric level. Also, we will provide you with everything that is common. You know how to make a point, a curve, a plane, a sweep, or whatever. But maybe you didn't think about using if then else. You didn't think about making loop, because I don't know how to use Python. I don't know, I need to ask an AI. But now you can do yourself. It's somehow better control. We provide specific features like the noise, Perlin noise, the Voronoi, which is something that you can see here. We provide you with normal random. We provide you with some specific features that were in the past available to mathematicians or developers. Now everybody can make it. And because of this, you can go to the next level of parametric models. So I try to show you things that you don't do today, but maybe you've dreamt about it a little bit. So imagine CATIA on steroid to help you model geometries like this, or behavior that were in the past available only through a collaboration with some university. I don't say you can still collaborate with big guys, but you are in a better ground to discuss. So some topics I put here is not product. It's to bring you just hoping that you can extrapolate to your own things. So I put some thema here like conforming transformation, like complex stylings, like reaction diffusion phenomena on a donut. Then, like this one is quite interesting. It's a soap film. I was seeing some soap foams, but I did some soap films, some coral growth, some organic shapes. It's not so difficult. This is marching cubes inside CATIA, out of reach in V5. This is L systems, like a fractal, when you want to do trees, sustainable experience. And something that you might see, this kind of shape, which was out of thinking until we try to see more and more different kind of manufacturing technologies. So this is a gyroid, and used for heat exchange, for example. Okay, so this said, I step back again. What I want to say is that this tool is fully integrated to the platform. And I chose the wind turbine blade design to illustrate a use case closer to current industrial needs. So this is coming from a UK customer. And how we make it accessible for the design operation, for loop iteration between design and simulation. So to optimize the surface quality and aerodynamics for wind turbine blade, it's usually very manual, very time-consuming, very difficult to automate. So now what we do here is we combine the design. The solution is a combination of visual scripting, CATIA ISEM, and Simulia fluid dynamics that Kurt showed right before. What we do with visual scripting is not to provide a model of a blade. So we do basically the automation of the Bezier sections, then we do very advanced surface. What we propose, what we have to give now to the simulation expert is a field, an exploration parametric field. It's not one model, it's 1,000, 10,000, 100,000 possibilities. But of course, it's not you to discover, to explore it. We feed it to Simulia, getting ready for AI, and the Simulia has got an optimization tool that gives you, upon your targets, okay, this set of parameters is good, this set of parameters is good, this is a good solution. And that was, I wanted to illustrate that the next stage to generative is not one model, it's a parametric field in one model in the platform for the ModSim process. So that makes a difference. So now this is the end of my presentation. I tried hard to illustrate the value of CATIA design in the platform. It's time's up. There are many, many more use cases, so feel free to reach me or my colleague of DS Taiwan, Vic, for deeper discussion. If I got one more minute, it's just to promote a yearly event that happened this year in Germany. It's a CATIA Creative Design and Engineering Days, and you can meet a worldwide expert. You can discuss with our other users worldwide. I think it could be a good investment to go there. Everybody is welcome. And this year, as a special guest, we had, you see, Volkswagen and BMW that made a nice testimony on how they moved to 3DX platform. Thank you very much.
各位刚刚看到卡奥的一个演说的内容，你会感受到现在的卡地亚跟以前你所使用传统的卡地亚非常的不一样。现在在我们的所谓的 3DEXPERIENCE 平台下的卡地亚，各位可以体验到，从你开始发想到后面，他特别提到了几个部分。Virtual Twin 在 Virtual Twin 的架构底下，你会发现到，你透过 VR、MR 沉浸式的部分，你可以开始透过这样真实的一个设计的一个应用到你的体验。而这个体验，你刚刚特别 highlight 到非常真实的部分，里面体验的部分，甚至到你的 MR 里面，你可以透过它去做一些实际上面基于人的动作，然后各位看到它搬付的一个行动，然后去验证你的设计是不是符合你的需求。那这些底层其实也包含了一些 AI， 因为你看到刚刚看到那个视频里面的人形的动作，跟我们真实的人非常非常的近似。然后还有一点特别的，我们从传统的渲染去体验我们的设计以外，他也特别提到，现在我们跟光学整合在一起，从传统的所谓的 ray tracing 光线的追击到光线 optical 的这个部分的应用，更凸显在这里面。当然，第二部分他也特别提到了一点 motion 设计跟模拟的一个整合，所以他用了一个明显的例子，我们在做造型的部分，车子的造型部分跟我们的空气动力学非常的相关，结合了我们在平台下结合我们的 Simulia 里面的一个所谓的空气动力学的 CAE 的一个模拟的一个情境，可以完全的呈现到我们可以跟模拟设计一体化，然后加速我们在设计上的一个优化。那最后还有一个很重点的，就是我们现在在做一些仿生设计的时候，希望它是一个很复杂的。那前面我们的一个客户 应用其实是一个非常真实的一个应用案例，它用在鞋子的一个花型的一个侧边，所以各位可以体验到，在这样子的一个复杂形状的设计上，你可以很轻易的在我们一个所谓的视觉化逻辑的一个定义上面很快的成型。其实那些成型的一个内容，就像我们可以抬头看一下上面这样子的一个花纹的一个定义，在我们现在的卡地亚里面，其实要做到这样子是非常的快速的。以上这是我跟对刚刚考号的部分很快的做一个总结，谢谢。